Hi astronomers, Caroline here. So far, we have visited the terrestrial planets, Mercury, Venus, Earth, and Mars, and the gas giants, Jupiter and Saturn. And now we have finally reached the outermost planets, Uranus and Neptune. These planets are the least explored in our solar system, but even with the small amount of data we have about them, scientists believe they may hold many valuable discoveries. Could a crewed mission make these discoveries? Or will we have to rely on other methods to uncover their secrets? Uranus and Neptune will be our final two planetary destinations. We'll first compare and contrast their size, distance from the Sun, and composition with the terrestrial and gas giant planets we've already explored. Then we'll discover what makes their seasons, temperatures, winds, and colors so different from the other planets. Let's get started. You might have heard Uranus and Neptune called gas giants, like Jupiter and Saturn. While they do have thick atmospheres of hydrogen and helium, they are actually better described as ice giants. Why do you think this might be? Unlike Jupiter and Saturn, which are mostly made of hydrogen and helium, Uranus and Neptune have much more water, ammonia, and methane, materials that were frozen as they formed. These ices make up a large part of their interiors, giving them a different composition and structure than the true gas giants. This distinction helps scientists better understand how planets form in different parts of the solar system. Like the gas giants, Jupiter and Saturn, Uranus and Neptune are much larger than the inner terrestrial planets and have rings and moons. They are the farthest planets from the Sun, which adds to the challenge of sending a crewed mission there. So, how far away are the ice giants? This diagram is a scientific model. It shows the distance between the planets and the Sun to scale. Look how far away Neptune is compared to our neighbor Mars. Neptune is 30 times farther from the Sun than the Earth is. How do you think their distance from the Sun and position beyond the frost line might affect Uranus and Neptune's temperatures and the materials they're made of? Pause your video and record your prediction in your notes. Now that you've made your predictions, let's dive into what makes Uranus and Neptune the ice giants and how this might impact a crewed mission. Beyond the frost line in the solar system, substances like water, ammonia, and methane could freeze into ices. Jupiter and Saturn, the gas giants, grew large by collecting these ices, and as they got bigger, their gravity became strong enough to pull in lots of lighter gases like hydrogen and helium. By the time Uranus and Neptune formed farther out, most of the hydrogen and helium had already been captured by the larger planets. As a result, Uranus and Neptune ended up with more of the heavier, icy substances, earning them the name ice giants. The term ice can be a bit misleading, though. While Uranus and Neptune were icy when they formed, earning them the name ice giants, the mantle, which is the area between the core and the atmosphere, is no longer ice as we know it. Scientists use the term ice to describe how the particles are arranged, similar to how they are in solid ice, but not to describe the temperature. Instead, the immense pressures within the planets, like we saw in the gas giants, along with extreme internal heat, have transformed the heavier, icier substances, such as water, ammonia, and methane in the mantle, into what scientists describe as a dense soup. This ice is quite different from any ice we have here on Earth. But could there be liquid water hidden deep inside these planets? Scientists believe that under the extreme pressure of the mantles, water and ammonia could remain in a liquid state, forming an ocean layer beneath the thick atmosphere. If this is true, it raises an exciting question. Could these hidden oceans hold the building blocks of life? While the extreme conditions make it unlikely,
Studying Uranus and Neptune helps us understand how similar exoplanets might support habitability.
With this soupy surface in mind, do you think we could send a crewed mission to the ice giants? You're probably thinking that, again, like the gas giants, there would be nowhere to land. Also, based on the trip of Voyager 2, the only mission to ever visit the ice giants, the round trip alone would take almost 25 years. Instead, scientists are studying the ice giants from a distance with the James Webb Space Telescope. Although Uranus and Neptune share many characteristics as ice giants, they also have their own features that distinguish them from each other. Let's explore these distinct characteristics and consider how they might influence a mission to explore the ice giants. Take a moment to observe the rings on Uranus. Do you notice anything that surprises you about them? Uranus's rings wrap around the top and bottom rather than around the sides like Jupiter and Saturn. This is because Uranus is tilted over 90 degrees on its side. Picture Uranus rolling around the sun like a giant ball and taking 84 Earth years to make one revolution. This lengthy orbit and extreme tilt mean that a single summer or winter lasts 21 Earth years. One pole enjoys a long sunny season, while the other is plunged into a deep dark winter. On top of this odd tilt, Uranus also rotates the opposite direction of most planets, like Venus does. What could have caused Uranus to behave so differently? Scientists hypothesize that a large object collided with Uranus, knocking it on its side and causing it to rotate in the opposite direction. This collision may also be the reason why Uranus has the coldest atmosphere among the planets, even though it's not the farthest from the sun. Scientists think the impact may have caused Uranus to lose a significant amount of internal heat, leading to lower atmospheric temperatures. Unlike Uranus, Neptune's internal heat remained undisturbed, powering the fastest winds in the solar system. These winds can travel faster than the speed of sound and create strong storms. And without land to slow them down, these storms can last for years, longer than here on Earth, but not as long as the storms of the gas giants. Neptune's fast winds and turbulent atmosphere interacting with the methane found there may also be why it appears a deeper blue than Uranus. So, could we send a crewed mission to these ice giants? It could be tricky. Just like the gas giants, there's nowhere solid to land on Uranus and Neptune, and their stormy atmospheres make even coming close dangerous. Not to mention that a round trip would take decades. Current technology limits us to studying these planets from a distance using powerful telescopes like the James Webb Space Telescope. But who knows what the future might hold? Advancements in space travel could one day make it possible to explore these distant worlds more closely. As we end our journey to the ice giants, you now know that Uranus and Neptune are large planets far away from our sun. They were mostly made from ices and have a dense, soupy mantle. Because Uranus rolls like a ball around the sun, it has long seasons. It is also the coldest planet in our solar system. Neptune has extremely fast winds and is a deep blue color. Based on the evidence we've collected about the conditions on all of the planets, where would you choose to send the next crewed mission? What factors are most important in your decision? We may not be able to visit the distant ice giants anytime soon, but learning about them can help us better understand our solar system and the exoplanets beyond. Be sure to check out the activities for this lesson to learn more about these ice giants. And always remember, you are out of this world. See you next time. Hey, hey.